Hey gang, it's Mr. OC here, and I'm coming to you from a screencast where I am hoping to be able to enlighten you on some decimal and fraction multiplication. So I'm going to go over the questions that we had on our quiz and show you a possible way that you could earn back some credit. So let's get started. Here we are. First question. Let me move myself. We have 3 and 8/10, that's how we say that decimal, 3 and 8/10 times 15. There's a bunch of different ways you could solve this problem. Here is one way to do it. You could break apart into addends. That's definitely a way that you could handle. All right, and so if I'm breaking apart into addends, then here we go. I can see my work here. I'm going to take the 3 and 8/10, I'm going to leave it alone. But I'm going to take my 15, I'm going to break it down into 10 and 5. Notice 15 is 10 plus 5. And now we're going to use what we call the distributive property. In other words, we're going to distribute 3 and 8/10. We're going to multiply 3 and 8/10 times 10. That's what you see right here. And then we're going to add it, notice this addition, we're going to add it to 3 and 8/10 times 5, which is over here. And again, that's called the distributive property. But we know it better as break apart into addends. So if that's the case and that's what I'm doing, then, well, 3 and 8/10 times 10, that's pretty easy. I know that's 38, right? Because when you multiply it times 10, you're really just moving the decimal one place. So here we go. I've got 38. But then I have 3 and 8/10 times 5, and that might give me some trouble, except I know that 10 is 2 times 5. And another way to say that is that 5 is half of 10. So if 3 and 8/10 times 10 is 38, 3 and 8/10 times 5 is going to be half of 38. Half of 38 is 19. Then all I have to do is add them together. Once again, we're going to see that addition sign. And 38 plus 19, when we add them together, is 57, which is the answer that you hopefully got. Okay, so that's break apart by addends. Another way you could have solved this is by rounding and adjusting. Sorry for my bad handwriting here. So we're going to round. Because 15 is right smack dab in the middle of 10 and 20, we're not going to round 15, but we are going to round 3 and 8/10. Now 3 and 8/10 is really close to a whole number that's easy for us to multiply. It's easy for us to multiply by 4. So I'm going to add 2/10 to 3 and 8/10 and give me 4 wholes. Then all I have to do is 4 times 15, which equals 60. I can remember that because I know that in 1 hour, there are 4 15-minute quarters. So I think of it that way. But you can do 4 times 15 however you like. So now I've got 60. That's my rounded answer. But now I need to adjust. Remember that I added this 2/10 here. So I'm going to need to figure out what 2/10 times 15 is. A lot of people are making a mistake. They're not multiplying 2/10 times 15. Well, you know me, I don't like decimals. I like fractions much better. So I'm going to rewrite this decimal as a fraction. 2/10 is here, 2 over 10. And I know 2/10 times 15 is going to give me 30/10. And 30/10 I can simplify very easily into 3. So I now know that 3 and 8/10 times 15 is going to be 4 times 15, which is 60, minus 2/10 times 15, which is 3. And that's going to give me my same answer of 57. Alrighty. So there you go. 2 different ways to multiply with decimals and whole numbers. But I want to give you a word of advice. I'm going to move myself one more time. Hope that doesn't freak you out too much. Alright. A lot of students were doing the traditional method, which is a totally valid method for solving this problem. Not an issue at all if you're doing it. However, many students either messed up using the traditional method because they actually don't understand what they're doing or explained it wrong. A lot of the comments that I heard were, I'm going to ignore the decimal. And I don't really understand what that means. You can't ignore the decimal. The decimal is important. I also had some students tell me they're going to multiply 5 times 8 and carry the 4. Carry the 4? What 4? I thought 5 times 8 was 40. So if that's a 4, does that mean 4/10? Got to really be careful here. After they're done multiplying 5 times 8 and then 5 times 3, or 5 times 30, then they have to multiply 10. And so I had some people say, well, we're going to add a 0 there. You're not going to add a 0. I don't really understand what that means. What you really need to do is understand place and place value. Once all the multiplication was done, students said, well, now I'm going to put the decimal back. What? Put the decimal back where? What does that really mean? So my advice to you is this. When you are discussing the traditional method, do not lose place value. Place value is super, super important. Let me explain what I mean here. Okay, so here is 3 8/10 times 15. Instead of saying I'm going to ignore the decimal, what I'm going to do is I'm going to say I know that if I multiply 3 8/10 times 10, that will give me 38. If I am multiplying by 10 now, then later I'll go back and divide by 10. That will give me my answer. So I'm going to do it this way. I'm going to think of it as 38 times 15. But when I do any kind of traditional method, I cannot deal with carrying because it doesn't make sense to me. I know that I have 4 things to do here. I've got to do 5 times 8, and I'm going to do this. I'm going to write it in. I'm going to make it kind of small here. I'm going to write in 5 times 8, which is 40. And then I'm going to do 5, and it's not 5 times 3. It's 5 times 30. And my 5 times 30 is 150. Then I don't need to write a 0, add a 0, whatever, because I know that this really is 10. So I'm going to multiply this 10 times 8. And if I do that, I'm going to get 80. And last but not least, I'm going to take this 10 again, and I'm going to multiply it by 30. And 10 times 30 is also easy for me to do. It's 300. Now, I'm going to add. And you can add however you like. I might do it like this. 40 plus 150 is 190. 190 plus 80 is, 190 plus 10 is 200. And then I've got 70 more, so 270. And then 270 plus 300 is 570. So when I do 38 times 15, I get 570. But now I've got to remember that I said later I was going to go and divide. So I'm going to go back and divide 570 by 10, and that's going to give me the same answer of 57. Okay, so again, I hope with decimal multiplication that you have some strategies that work, but that also you're never losing sight of place value. Here we go into another neat problem, which was our fraction multiplication problem. Our problem was 4 5/6 times 24. I really hoped that this was going to be a slam dunk for you. So let's investigate 2 different methods for how to solve it. The first method that we're going to use is rounding and adjusting. Good old rounding and adjusting, which we use with decimals as well. So I'm going to take 4 5/6 and then 24. 24 seems to be kind of in the middle of 20 and 30, so I don't think it's going to help me all that much. But 4 5/6 is awfully close to 5. So I'm going to make sure that I add 1 more sixth to get to 5. So now I've got 5 times 24. And that's a pretty easy problem for me to solve. 5 times 24 is 120. If that's troubling, you can remember that you can actually break it apart into add-ins again. I can do 5 times 20, which gives me 100, and then 5 times 4, which gives me 20. 100 plus 20 is 120. But then I added that 1/6. So I've got to remember that I still need to find 1/6 of 24, which again is 1/6 times 24. I can't just adjust by subtracting 1/6 because it's 1/6 of 24. Now one way to think of 1/6 of 24 is to take 24 and divide it by 6. Hey, I'm in luck. That's actually easy to do. I know 6 times 4 is 24, so 24 divided by 6 is 4. So that's the adjustment that I need to make. 1/6 of 24 is 4. I had 120 when I multiplied 5 times 24. So I take my 120, I subtract 4, and I get my answer, which is 116. That's one method for solving this problem, but it's not the only method. Let's take a look at another one. Let's break apart into add-ins again. See if I can move myself into a place where I'm not going to be thought of so badly. I'll move myself again in a second. Here we go. So I'm going to rewrite this in a way that is going to make it a little bit easier for me to see. And I'm going to take the commutative property and just switch the order here. Then I'm going to use what I know about breaking apart, which is, once again, the distributive property. And I'm going to take 24 times 4, and I'm going to add it to 24 times 5/6. I can do that because 4 and 5/6 really is 4 plus 5/6. Okay, so now what do I do? Well, 24 times 4. If I move myself back up to the corner, breaking apart, I'm moving myself. I know that 20 times 4 is 80, and 4 times 4 is 16. I can add them together to get to 96. And then I have to do 24 times 5/6. So 24 times 5/6, that seems kind of tricky. How would I do that? How would I do that? I'm going to think over here that I know 24 times 5/6 is the same as 24 wholes times 5/6. I also remember the commutative property, which tells me that I can switch the order of things that I multiply. In this case, I'm multiplying the denominators. So I'm going to switch the order of the denominators, which means I'm going to switch this 1 and 6. My new problem is going to give me 24 divided by 6 times 5. Well, 24 divided by 6 times 5 is going to give me 4 times 5, because 24 divided by 6 I already found is 4. So now I just have 4 times 5, and 4 times 5 is easy. 4 times 5 is 20. So now I just have to do 96 plus 20 to get to 116. And there we go. Once again, that's my answer, 116. So a couple different ways that you could solve it. Another way that I saw a lot of students doing, and this was a really neat method, was basically taking the traditional method and making it easier. Let me move myself again. The traditional method and making it easier. However, there were some issues here in terms of students explaining the traditional method. A lot of students told me that 4 and 5/6 is 29 over 6. That is true. But a lot of students didn't really seem to understand why. I've drawn a picture to try and help us understand why. So here's my picture. I've got 1 hole, 2 hole, 3 holes, 4 holes here, right? And you can see that I've got that 4 right there. My 4 holes each have been divided into 6 pieces. Then I've got 5 other pieces. Notice they're the same size. I don't have a 5th hole. I'm missing that 1 piece. But if I divide each one of these holes into 6 pieces. Let's see, I'm not there anymore. There we go. If I divide each one of these holes into 6 pieces, you'll see that 1, 2, 3, 4, 5, 6. Each hole has 6, so I've got 6 here, 6 here, 6 here, and 6 here. Or 4 times 6 for 24. And then I have those additional 5 over there. So really, why is it 29/6? It's because in 1 hole there are 6. So in 4 holes, there are 24. And then I've got an additional 5. So that's 29/6. So now back up to my problem. I have 29/6 times 24. I'm going to use the commutative property again to help me out because I think it's going to be a little bit easier for me. And what this problem really means is what I would have to do is multiply the numerators, 29 times 24, and then divide it by 6 times 1. But remember that I can switch the order. So I'm going to switch this 6 and this 1. So I'm going to make it 29 times 24 divided by 1 times 6. I just switched the order. Well, I can separate that back out and make it 29 wholes times 24 over 6. But I know 24/6 is the same as 4. So now all I have to do is 29 times 4. And if I am having trouble with that, I can remember here that 20 times 4 is 80, 9 times 4 is 36, and then 80 plus 36 is 116. Okay, so there's 3 different methods for solving. If you would like to improve your score on these quizzes, here's what you can do. Go to Screencast-O-Matic and pick a decimal or fraction multiplication problem and explain it to me, just like I've explained one way to solve them for you. Or use Seesaw, which is a program you use, I hope, in 6th grade, and we've started to use it a little bit in 7th grade, but we can explore it more. Most importantly, if you need help, please ask. Thanks a lot.